All right, we're back with video number 2. It looks like we're talking about some basic terminology, some definitions, and then just how water behaves beneath the ground. So pause the video, make sure you look at the learning targets, and make sure you have something ready to take notes, however you're taking notes.
All right, so like we talked about or mentioned in the first video, water doesn't exist underground in these void spaces. I mean, unless it's a cave or something like that, but most groundwater, like we said in the last video, was found within the pore spaces of rock, and it flows through there. And the rate at which it flows is permeability. So just a quick review. But this picture over here, although it's definitely from Earth, and it's possible, but it's not as common, and it's not that we get water from places like this.
Okay, so we're going to start to dig in on some of the basics and the basic terminology about groundwater, and we're going to start with the different zones under the ground. So we have to try to think about what's under our feet and what we know about that. We're going to start with the first zone being either called the unsaturated zone or the zone of aeration. And I kind of like to remember that it is called the zone of aeration because that helps me remember that the pores in between the unconsolidated sediment or the pores in between soil grains are full of air and or water, but they're not fully saturated with water in that zone, right? Okay.
So as we move further down at the end of the unsaturated zone, we run into something called the water table. Move to the next slide.
Yeah. So with the water table, this is where you dig down and essentially you're hitting water. So if you were to dig a well, or like I think when I was digging at the beach, like last weekend, because I still do stuff like that.
It was snowing.
But you dig a hole, and as soon as you hit water, that's the water table, right? And so what's going on with the pore spaces there?
Well, the pore spaces at the water table begin to be filled with water. And then everywhere below that water table, we're going to call the saturated zone. And if we think of something as saturated or a sponge or something like that, that's saturated, it's full of water. So all the pore spaces in the saturated zone are full of water, and the water table marks the height of the zone of saturation.
And at that interface between the unsaturated zone and the saturated zone at the water table, we have this little area called the capillary fringe. So the way I like to think about it is if you take a paper towel and you just dip it into water, water gets sucked up into the paper towel. And that's a similar situation with the capillary fringe, where you have little bits of water being sucked up into the pores in the unsaturated zone at the top of the water table, right? Okay, so we've got the unsaturated zone on top where the pores are filled with air and or water. We have the water table that separates that unsaturated zone from the saturated zone where the pores are full of water. And the capillary fringe at the top of the water table. Okay, good. Let's go on.
So if we take a look, the water table, for the most part, is going to basically mirror what the topography looks like at the surface. If you've got a higher point in elevation, like a hill or a mountain, your water table is going to somewhat mimic that. So it's going to take the same shape. So if you look at the picture there, they've got the wet season water table and the dry season water table. Dry in the dash line and the solid line for wet. It kind of takes the same shape of those hills there.
Okay. So I'm guessing we have to be careful of that variation between the wet and the dry season when we start to talk about wells. Okay, good. Now thinking about how the water gets into this saturated zone, and actually we haven't given the saturated zone a name yet. So we've got the unsaturated zone, the water table, the saturated zone, and this saturated zone has a name, and it's called an aquifer, right? So we have water flowing through this aquifer. Well, how does it get into the aquifer? And there are a couple of ways that water can get into it or recharge an aquifer. One of the ways, simple way, is rain or snow falls on the surface, soaks through the soil layer, the unsaturated zone, makes its way down into the saturated zone, and recharges the water in the aquifer. What are other ways?
You could have melting snow.
Okay.
So like right now it's winter by us and all the snow's starting to melt. Some of that water, as it melts, infiltrates into the soil. It recharges some of the aquifer.
Okay, and then water flowing out of the aquifer?
Would be like a river. So we can see, or we could see a river that would be flowing, would also be taking groundwater out of the system, and then also pumping water out of a well could also be taking water out of the system.
And when we're taking water out, we have a special name for that, and that's discharge. So it's recharge when the water is going in to fill up the aquifer, and it's discharge when the water is taken out by whatever method it's taken out. Okay. All right, let's go on.
So we've got kind of a special scenario here. This is called a perched aquifer. Now I think a bird's perch, so it's kind of up in the air. It's perched up a little bit.
Yeah.
So if you look at the picture on the bottom right, we have what's called an aquiclude. Okay, and basically that's something that's not going to be very permeable. Okay, it doesn't let water flow through it. So any water that falls on top or infiltrates on top is going to get like stuck above it.
Okay.
Okay, and it's actually above the water table where it's at. So it's almost like a mini water table or a mini aquifer right there.
So another term for aquiclude is aquitard.
That's right.
And if you think about it that way, the aquitard retards water from being able to flow through it. So whichever term you happen to hear one of us say, they mean the same thing. And we get a special situation when we have an aquiclude or an aquitard that's creating that perched water table. What happens when the water flows out onto the surface?
So if you notice there, you can see that the perched water table is right kind of alongside of that hill, and water can actually flow out of the ground, and that's referred to as a spring. The recharge area is kind of above at the top of that hill. It's not only recharging the perched aquifer, but it's also recharging the other regular aquifer that's below that.
So when a water company is talking about natural spring water, they're talking about water that's coming out onto the surface. It's flowing out onto the surface by itself, right? Okay, got it. All right, so that's the last slide for video 2. Jump out, take your quiz, and we'll see you in class tomorrow.
See you guys.
Bye, guys.